Hi, welcome to page 3. So we're working with real-world application types of problems. So when a natural preserve started, it counted and tagged 15 deers after 15 deer. Gosh, what? Right, plural for deer is deer. After 8 years, the group of deer is growing exponentially and is now up to 2,879 deer. Round your answer to 3 decimal places. Okay, well, they're not giving me a question. So I'm guessing that's where we're eventually going to go. So it says determine a rule for t, the number of deer in the preserve after t years. So a couple things that we know is when it started, so when the t is equal to 0, we know that there were 15 deer. So like let's say d is going to be equal to my deer. Then I know after 8 years, then we end up having the number of deer is going to be 2,879. So how do I figure out this specific exponential function? How do I know how much it is growing by? So what I want to do here is I want to treat this as almost like a graph with trying to figure out the value. So this is going to be 15 right here, or because when t is equal to 0, that's going to be 15. And then we know that when this is 8, this up here is going to be 2,879. And so we know that it spikes up pretty quickly, like that. There's my exponential function. So I'm going to write this as the following. Y is equal to a b to the x. So we did these types of problems before in terms of graphs. Now we're doing in terms of word problems. So if I end up saying, let's say I'm going to write that equation a little bit differently. I'm going to say y is equal to a b to the x, but then do it in terms of like the deer and other things like that. So I'm going to say deer is going to be equal to a times b to the t. And I know that since this is the starting value, if I place in t is equal to 0, doesn't that make this t 0, this b value 1, because b raised to the 0 is going to be 1, so then a is actually going to be equal to the d, which is going to be equal to 15. So I'm going to say d is going to be equal to 15 times b to the x. Then what I want to do is I'm going to use my other order pair. Oh, not x. I'm going to do t. And then I'm going to use the other order pair 8 and then 2,879 as my guide. So I'm going to do 2,879 is equal to 15 times b to the 8th power. I'm going to divide everything by 15. So I end up getting, let's type this in my calculator, 2,879 divided by 15, which ends up giving me, oh gosh, not even a nice happy number. So I'm actually just going to do that as, let's see, I can zoom in. So 2,879 over 15 is equal to b to the 8th. Now, how do I undo b to the 8th? Well, I'm going to do the 8th root. Now, there is no 8th root in your calculator, but what you can do here is you can type in the following to get your value. So I'm going to type in b is equal to, parentheses, 2,879 over 15 to the 1/8. Now, you need to make sure that that 1/8 is in parentheses to get the most accurate value. Now, you could have estimated, in a sense, this number right here, but it's not really going to be helpful in terms of getting the most type of accurate number. You want to try and type in as much or as accurate the numbers that you can before you start to estimate for your final value. So I'm going to type in parentheses 2,879 divided by 15, and then caret, open parentheses, 1 divided by 8, close parentheses, and you should get your b value to be 1.929. All right, so then the equation is going to be d equals 15, right? That was the starting deer. Then 1.929 raised to the t power. That is, in a sense, your equation that you need for this. Then says, find the average rate of change of growth of the deer from the interval from 0 to 3. Now, in class, we did not talk about rate of change, but rate of change is really just referring to as slope. And we did sort of talk about rate of change at the very beginning of the year. That is, it seems that thing is saying y2 minus y1 over x2 minus x1. Or another way of saying this is f of b minus f of a over b minus a. So what I'm going to do here is I'm actually going to graph this equation y is equal to 15 parentheses 1 1.929 to the x power. So when I graph that, 15 parentheses, 1.929 to the x, and I hit graph, and it's going to show me what a graph looks like, and it's going to spike up real fast and all that stuff. But really what I'm concerned with is I'm really concerned with what the value is at 0 and what the value is at 3. So this is going to act as my A, and this is one's going to act as my B. I'm going to use these two formulas, well, that formula, to kind of set up the A value and the B value. So I'm really saying, what is the f of 3 minus f of 0 over 3 minus 0? So with this problem, I'm going to go to second table, and I'm going to figure out what the value is at f of 3 and what is the value at f of 0. Well, f of 0 looks like that's going to be actually a 15. And f of 3, let me just set my table set. My table set's at a weird value. And at 3, looks like that's going to be at 107.67. So if I do 107.67 minus 15 over, in a sense, 3 minus 0, which is 3, that will give me my answer. So that will also give me my quote-unquote rate of change, or also known as the average rate of change. And I should get 30.89. And so the way how to kind of set this up, this would say deers, or deer, per, and then since we're talking about years, this would be deer per year. So it'd be 30.89 if we were comparing the 0 to 3 interval. Okay, number 10. So it says Khalil has saved up all of his money, of his family's money, has given him for his birthday, holidays, specials, occasions, and he's ready to buy a car. He decides on a practical car that's going to cost him $15,500. His sister teased him that she read an article that his car will depreciate in value of 12% yearly. So what would the rule be to represent this situation? Well, so his car right here is going to be worth $15,500. Okay, since it depreciates in value, that means it goes down. So we're going to say 1 for the amount of his car minus that specific rate. So it's going to be 1 point or 0.12. And then for every year, so that's going to be t is equal to, in a sense, the amount of his car. And that's modeling off of the amount is equal to principal times 1 plus r to the t power. But this time the r is not actually making the value go up, it's making it go down in value. So it says, what would his car value be in 6 years when he graduates from college? It should be 4 years, not 6 years. So 15,500, right, should only take you 4 years to finish college, unless if you go to law school or pre-med, or you get your master's or other things like that. So I'm going to say 15,500 is equal to 0.84, nope, 88, I would say. And then raised to, in a sense, the 6th power. And then just type down in your calculator 15500 parentheses 0.88 raised to the 6th power. And that's going to roughly give you $7,198.26. And since we're dealing with money, we want to round to the nearest cent. And then it says, what is the asymptote for the function rule representing the situation, and what does that mean? So in this context, right, if we kind of look at how the graph goes, this is really saying, this is my A value, this is my B value, this is my X value, or T. But since it doesn't move up or down, we would actually have a horizontal asymptote, which is still at y is equal to 0. And so what's happening here is that this graph gets, right, there's some type of value that starts at, and then it gets closer and closer to technically 0. And since it gets closer and closer to 0, but doesn't ever actually touch it, that means that the value keeps getting closer and closer to 0, but the car will never not be worth anything, right? So the car will always be worth something, but just the value just keeps decreasing in value over time. And that's really kind of what they're trying to describe here. So the car is getting closer to the value 0, but will never be worth nothing. Okay, number 11 says scientific experiments in Slovakia went terribly wrong. This is my zombie invasion kind of thing. So in 2020, there were 45 million zombies. In 2030, there is 1 million, 108 million. So write an exponential function that will represent this. So just to kind of make things a little bit easier, I'm just going to use 45 and 108 as my numbers, and then I can just tack on millions after that, because it doesn't make sense to put on 6 zeros after that and just kind of fill up my whole, in a sense, my whole page with this. So we're going to refer to zombies, comma, the time. So for the first one, it was 45 million zombies, and a time, in a sense, let's say that it starts at 2020, or that's my first point that I get, so I'm going to say t is equal to 0. And then after a specific amount of time, there was 108 zombies. And then that was 10 years later. So that is zombie and in time. Okay, it says write an exponential model that represents the zombies where t represents the number of years since 2020. So that's good because this is actually year 2020. Okay, so as I kind of talked about before in problem number 9, that order pair for the first point, this is actually going to be, in a sense, I have this actually backwards, right? That's actually going to be, this is going to be the x value, this is going to be the y value. Let me rewrite this. So we're going to say at time 0, that's going to be 45 million zombies. And then at time 10, there's going to be 108. And so this actually ends up being our a value. So we're going to say y equals, or you could say the amount of zombies or z or whatever. The a value is going to be 45. And then we're going to say b to the t or x or whatever type of variable that you want. Now we're going to use this second order pair to determine where that's going to be. So 10, 108. So this is going to act as my t value. This is going to act as my y. So I'm going to go 108 is equal to 45 b to the 10th power. Let me guess. This is not going to divide evenly, isn't it? So I'm going to get 108 divided by 45. Does that even simplify down? Yeah, it does. Okay, I'll do that. So I'll say that that's going to give me 12 over 5. 12 over 5 I got basically by dividing 108 divided by 45. So that gives me 12 over 5 is equal to b to the 10th. Then do the 10th root to both sides. So that's another way of saying 12 divided by 5 raised to the 1/10th power. Remember, that needs to be in parentheses to get my b value. So just to kind of do that, I'm going to write parentheses 12 divided by 5, caret, open parentheses, 1 divided by 10, and you should get 1.09 is equal to b. Let's round 2 decimal places. Okay, it says, what is the percent of rate of change? Maybe I'll actually go a little bit further because if I'm dealing with percentages, that might change things a little bit. Okay, let's go back. So that's going to be 1.0914934426. Just making sure I have that value. So the equation I want to write is y. Actually, let's do things in terms of zombies. So z is equal to 45, parentheses, 1.09. Here, you want a little trick. So 1, 4, dot, 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 open parentheses, and then raise to the t power. So that you just don't have to rewrite all of them. And then you could say, like, that is linked up with that one. And I'll understand what that means. Okay, it says, what is the percent rate of change? So really what we're doing here is we're saying the value that's inside here is 1 plus some other type of number. So in a sense, what I would do is I would just remove that 1. So it would be 0.0914934, which in turn is going to be 9.1, and I would probably say like 5%. And then it says use one of the models to determine the nearest millionth of zombies in the year 2060. So that would be a 40-year difference. So t is equal to 40. Oh gosh, this is going to be large, isn't it? So on the top of already millions. So word of caution, don't release any monkeys. Or what were the other ones? Just don't do experiments. Just don't release a zombie apocalypse. That would not be good. So anyway, 1.091493426. I'm going crazy in terms of the amount of decimals I really need. In fact, that value is actually in my calculator, so I can just keep referring to it. So I'm going to type in 45 parentheses my answer from before, then raised to the 40th power. And so I end up getting z is equal to 1,492.992. Now you have to remember that this is in terms of millions, so you could say millions, or you could write this as 1,492. So that's millions, and then 992,000 zombies. Okay, I'm going to stop here. I will probably finish the rest of. Oh, I still have a lot more to do. So I'm going to stop right there. I'm at 15 minutes, and I'll catch you later. Thanks.